So in the previous video, we saw how we can push multiple items at once to our stack. So here we are seeing the opposite of that. And we're gonna see how we can pop multiple items basically from our stack. And here we have, again, we have our registers, we can see what the content is, and we have our memory. And this is the high address, this is the low address, as you can see by comparing the numbers here. So the stack pointer, which always points to the top of the stack, is pointing to address ending in B4, which is this location. So that means this is our top of the stack. And that is our last item. So if we are removing these items, we said when we are removing an item from a stack, we have to basically increase the address of the stack pointer, or we have to move a stack pointer to a higher address. And the reason is that because let's say if we pop this from the stack, so we remove this item, the stack pointer was here. So after that, the stack pointer should move here because this location is not valid anymore. That item is removed. So it's increasing. So how we can remove this item? So first of all, we are doing a load word because we have the data in our memory and we are taking data from our memory to our registers. So it's a load word. And for each of them, we are using the stack pointer. And again, you have two options. You could either basically use here positive offset. So you would, for the first one, you are pointing here. And then for second one, you are pointing basically +4 and then +8 without moving your stack pointer. So that would be one option. The other option that is shown here, so by the way, that would be similar to the previous one, that you are first doing your offsets and then you are moving your stack pointer. Here, we are first moving our stack pointer. So the stack pointer is here. So we're gonna put it basically on the new top of the stack after removing the items. So we are removing this tree and the stack pointer is here. So it should be here. It should be pointing here at that point after removing the items. So basically that is offset of 4, 8, 12. So that's why we are adding 12 to our stack pointer. Then after that, when we are doing our load word, so for this element, let's say we wanted to have in register 13. So we want to save this in register 13. We are doing offset from this location now -12. So we are going back here basically and read that and put it in register 13. For the next one, we are doing offset of -8. So that's gonna be here because our stack pointer is moved at the beginning. And then for the last one, we are doing offset of -4. So it's here. So we are taking this one and copy it to the register 11. So if I did this the other way, meaning that I did the load words first and then I updated this, here I would get the first one would be 0, second one would be 4, and then 8. And then I had to move this one 12. So I would end up with exact same results. But the reason that we have it like this is that you're gonna be doing this operation a lot, that you're gonna push some stuff or push some data to your memory, and then at some later point you want to pop that data from your memory. So you're gonna be repeating this process many times. So first, let's say you push 3 values, and then later in your code you are popping that 3 values out from your stack. So you're gonna be repeating this, pushing some values and then popping them from your stack. And putting it in this way, you're gonna get the same offsets because in the other way it would be basically 0, 4, 8, 12. But in this way you are getting only 4, 8, 12, and it's gonna match exactly with what we had here. You see here you have also for the push, you had -4, -8, -12, and here you have the opposite, -12, -7, -4. So it's basically the same thing, and you can put it in the same way, by the way, it doesn't matter. So the idea is that you are exactly reversing this operation. So instead of save word, you have load word, and you are basically reversing every step. And that's why, since you're gonna be doing this a lot, pushing some data and then popping those, if you put it in this way, it's kind of easier because you can have the same instruction just in a reverse order, and it works. So let's see how now step by step. So here we have these 3 registers are empty. After doing this one, so the stack pointer is pointing to the address ending in 06, which is here. Well, actually before it was before, it's here. And then after running this add I, adding 12 to that, it's gonna become here. So you see this before, and then it's become to 06. So this is after executing this one. And then if you run the next line, we are seeing that we are copying this data that was that 33 to location or register 13, because the pointer is here, the stack pointer, and we are reading offset of -12 from that. So that would be here. So we are reading this data, copying it to register 13. The next step, we are reading offset of 8. So that's going to be here. And that data going to go to register 12. The next step, we are reading offset of -4. So again, that's from the stack pointer, which is here. So that means this location. And we are taking this and putting it in register 11. And basically that's how you can pop multiple items kind of at the same time from your stack back to your registers.